Just as a review, today in class we talked about the difference between ionic bonds and covalent bonds. We said ionic bonds are bonds that occur between a metal and a nonmetal. And we said that in an ionic bond, the electrons in the bond are not shared at all, but one element rips the electrons away from the other. And the way that we decide whether an ionic bond forms or a covalent bond forms is by looking at the electronegativity difference between the two elements that are involved in the bond. So we said that if the electronegativity difference, or END for short, is greater than 1.7, that would be considered an ionic bond, whereas if the electronegativity difference is less than 1.7, that would be considered a covalent bond. Just to review, for covalent bonds, we said covalent bonds occur between nonmetal and a nonmetal. And so the way to decide whether a covalent bond forms is if you look at the electronegativity difference and it is less than 1.7. And there are actually two different types of covalent bonds. There are polar covalent bonds and there are nonpolar covalent bonds. And the difference between these is that in nonpolar covalent bonds, there are no poles, whereas in polar covalent bonds, there are poles. And what we mean by poles are sort of areas, not that are fully charged, but that have partial positive and partial negative charges. So in a nonpolar covalent bond, the pull for electrons between both atoms is almost exactly equal, whereas in a polar covalent bond, one atom isn't strong enough to rip the electrons away from the other atom, but the pull isn't exactly equal. So we can look at the electronegativity difference to determine whether a bond is polar covalent or nonpolar covalent. A polar covalent bond has an electronegativity difference of 0.3 to 1.7. And a nonpolar covalent bond has an electronegativity difference of 0 to 0.3. So in a polar covalent bond, the atoms have slightly different poles for electrons, whereas in a nonpolar covalent bond, the atoms have almost exactly the same pull for the electrons. We ended class today by talking about the kind of bond that would form between the atoms Na and Br. So we looked at the electronegativities of each of these on the table of electronegativity that I handed out at the end of class. We saw that the electronegativity of Na was 0.9 and that the electronegativity of Br was 2.8. So when we looked at the electronegativity difference, we saw that it was 2.8 minus 0.9 is 1.9. So we knew that that meant that this was going to be an ionic bond that existed between Na and Br. And like we said before, in an ionic bond, one atom rips the electrons away from the other. So it's important to know now which one is going to rip electrons away from the other. So we need to take a little detour and talk about the electrons that actually get ripped away. When we talk about the electrons that get ripped away as two atoms are bonding, or the electrons that get shared as two atoms are bonding, we're really talking about the valence electrons. Which are the electrons in the outermost shell, and these are really the only ones that we're going to be concerned with. So anything in the first column has one valence electron. Anything in the second column has 2. Anything in the column with aluminum has 3. With carbon, 4. Nitrogen, 5. In the oxygen column, 6. In the fluorine column, 7. And in the column with helium and the other noble gases, 8. So let's go back to our example from before. Because sodium is in the first column, we know that it has 1 valence electron. So we could represent it by drawing it like this. Na with a single electron. And because Br is in the column that has 7 valence electrons, we could represent it by drawing it like this. Br with 7 electrons surrounding it. And we tend to draw these electrons in pairs just to keep it neat. So what do you think is more likely? Do you think it's more likely that Br is going to take sodium's 1 lone electron, or do you think it's more likely that sodium would take the 7 electrons from Br? And one thing to keep in mind, in case you haven't heard this before, is that atoms are always trying to have a full octet, or they want to have 8 electrons in their outer shell. So they want 8 electrons in their outer shell in order to be stable, and that's the reason that they bond. So in order for sodium to have 8, it could either lose the 1, because then the shell beneath it would have 8, or it would need to gain 7 more. In order for bromine to have 8, it could either gain the 1 that sodium has, or it could lose the 7 that it has. And if we look at the electronegativity table, we know that bromine has a stronger pull for electrons than sodium does, so it will take the 1 electron from sodium. So it will leave sodium with no valence electrons in that shell. So we would draw it like this, and because it's lost an electron, we would show it as an ion, which means we would put it in brackets and write a plus sign. And bromine, because it has gained an electron from sodium, also becomes an ion. So we would draw it like this. Also in brackets because it's an ion and it has a charge of -1. And then the bond forms because of the positive charge and the negative charge that sodium and bromine both have. Now let's look at what happens if 2 chlorine molecules are going to bond. So if we have a chlorine and a chlorine, it's not surprising that they would have the same electronegativity. So we could look at the electronegativity, and they each have an electronegativity of 3, so their electronegativity difference is 0, which is not surprising because since they're the same element, they should have the same pull for electrons. So that means that a covalent bond would form between them because they would share electrons equally because neither one is stronger than the other. So if we draw these 2 atoms, each having 7 valence electrons, we could draw them like this. There's one, and here's the other with its 7. So keeping in mind that both of the chlorines would like to have 8 in order to be the most stable and have a full outer shell, it could share 2 of its electrons so that they both have 8. So here are the 2 technically that would be shared, and we could draw the structure then like this. If we just draw them closer together, since they're sharing the 2 in the middle, each chlorine technically has 8 valence electrons. The structure here, where we use dots to represent electrons to show what different molecules look like, are called Lewis dot structures. And the remaining videos that you need to watch for homework will cover more on Lewis dot structures and how to draw them.